Great. Hi, everyone. I'm Rohan Basu Roy. I'm a PhD student at Northeastern University, Boston. And today I'm going to talk about what are some of the problems that I faced while executing HPC applications in different kinds of serverless computing or fast environments. So a lot of us are aware of that HPC applications are gradually getting shifted from this monolithic type applications to being designed as dynamic acyclic graphs or DAGs. And what these DAGs basically are, they have different components and then different phases of execution. And in each phase, there are multiple components that can be invoked. This has several advantages in terms of maintaining, updating these dynamic acyclic graphs, especially in serverless context. Each of these components can be invoked and executed in different serverless platforms as a separate serverless function. So what that means is that unlike traditional on-premise HPC, you don't really need to allocate resources. You don't suffer from the problems of resource underutilization or resource overutilization. So this provides all this kind of flexibility along with like pay-as-you-go billing model, which is very famous in production serverless systems. But there are several disadvantages to this approach also, and that is what we are going to talk about right now. The first disadvantage that I have always faced is that cold start is obviously a very big problem in serverless, both in for HPC applications as well as for like general in like enterprise serverless applications. What it means that it really slows down your total execution time, it increases, and that can be problematic in certain cases. But one thing that we noticed in case of HPC applications is that, or in case of HPC DAGs, is that the number of components invoked in different phases of execution follows some kind of distribution, and that can be easily fitted in form of a Weibull distribution. So the idea over here is if you can find out what Weibull distribution they are following, if you can find out the parameters of that Weibull distribution, you can actually predict what components will be invoked later and how many number of components will be invoked later, and accordingly couple the code of that component and warm start or hot start these components. This is what we do in our paper Daydream, which was published in Supercomputing last year. We hot start multiple components even before they are invoked, so that to avoid this whole cold start problem. And in this way, our main objective of this work is to reduce the overall cold start overhead and to improve the service time of different HPC applications. The next problem that we face is that the problem of scaling time. So like in general enterprise serverless application, as well as number of components in an HPC DAG, they can be large. The number of concurrently invoked components can be in the range of multiple thousands or even tens of thousands. And in that case, we observe that the scaling time can be a significant portion of the service time. The service time is defined as the summation of the scaling time and the execution time of a particular component. And we see that for like a concurrency of 5,000, your total scaling time can be like over 70% of the service time. This is really problematic, and it becomes worse and worse as your concurrency increases. So the idea over here is to reduce the number of functions that are being invoked. So how to do it is to pack multiple components or multiple functions inside one particular function instance. So by packing multiple components inside a particular function instance, what you will be doing is that you will be reducing the number of concurrent functions invoked or concurrent function instances invoked, and thus you will reduce the total scaling time. However, you cannot just randomly pack components because different components might contend for similar resources in a particular serverless function instance, and that might slow down your application. So what we did is that we designed an optimizer which studies how the computational characteristics of these different components and accordingly collocates them in a function instance to minimize the service time as well as cost. And this was published in HPDC this year. And an interesting thing that we observed, that we implemented this approach, which we call ProPack, on FuncX, and we saw that by packing multiple function in a serverless function instance, we can actually make FuncX scale 22% faster than AWS Lambda, which is a very well-known production serverless platform at a concurrency of 1,000. And if we increase the concurrency, this improvement actually improves slightly. The third challenge that we observe is that in production serverless platforms like AWS Lambda or Google Cloud serverless, these functions cannot directly communicate with each other. And thus, you cannot perform MPI as you can perform when you're running it in a on-premise cluster. And these functions, to communicate and perform this kind of I/O, they have to perform via an external storage, maybe an external block-based storage or a file system-based storage. And this brings in additional overhead, and your I/O time increases, as well as since you're allocating an extra storage and bandwidth, your I/O cost also significantly increases, and that can be a significant that can bring in significant slowdown in your application and affect your service time and your total cost. And so this is an ongoing work which is not yet published, and but the idea over here is to design a kind of optimizer and exploit and exploit the different storage options that is available in a production serverless environment. Let's say in AWS, they provide different storage options like S3, elastic file system, the temporary storage of serverless function, and to understand what component corresponds best to what kind of storage, and accordingly co-locate components inside a function instance and assign the storage so that you can reduce the overall overhead. So these are the main problems that I have experienced related to scaling time, cold start time, as well as your I/O time of executing HPC applications in serverless platform. And hopefully we can solve these. Thank you. That's about it for my talk.